The Earth's surface is dynamic, as illustrated by the relief of its continents. The science of geology allows us to uncover the ancient history in its rocks. Here, through the north end of the Bighorn Mountains, where the Bighorn River lies, a canyon has formed, one whose scenic walls are rich in geologic history. Throughout this remote, majestic region, time may seem to stand still. In fact, over time, the powers of nature have been at work, carving the rocks. And while it may appear as if this sculpted canyon is an end result, despite the placid lake which occupies the canyon today, the sculpting goes on, and the landscape continues to change. So, why is Bighorn Canyon here now? The geology of Bighorn Canyon dates back over 2.5 billion years and took place in 3 phases. First, sediments accumulated to form thousands of feet of rocks. After that, enormous forces uplifted and deformed these rock layers. Finally, erosion wore down the landscape and created the canyon. Let's examine the rocks. How did they form? To find out, we must experience millions of years as if they were seconds. Bighorn Canyon began as a vast granitic plain, made up of rock over 2.5 billion years old. During the Paleozoic Cambrian period, about 500 million years ago, the sea invaded, depositing the Flathead sandstone. As yet, erosion in the canyon has not exposed this layer. Later in the Cambrian were deposited the Gros Ventre and the Gallatin limestone formations. In Bull Elk Basin, where the Bighorn River has cut deepest, these occur as thin-bedded limestones and shales and a distinctive green pebble conglomerate. Water is responsible for many of the canyon's rocks. During the Ordovician period, a marine environment predominated, laying down the Bighorn dolomite. Its consistent composition produces uniform cliffs, such as these in Bull Elk Basin. During the Devonian period, the Three Forks shale and Jefferson limestone formed in a shallow water environment. As seen here near Bull Elk Basin, these contain mostly shale, weathering into slopes suitable for vegetation. 350 million years ago, during the geologic period known as the Mississippian, the Madison limestone began accumulating. Its thickness reached over 700 feet. Resistant to erosion, except where the river crosses it and dissolves it. The Madison limestone forms the cliffs along the length of Bighorn Canyon and also causes the plateau beyond the canyon's rim. In places, fossil brachiopod shells document the life in that ancient environment. In some locations, the Madison limestone appears orange-red. This color, however, is from iron oxide in the overlying Amsden Formation. Near the end of the Mississippian and into the Pennsylvanian period, the Amsden covered the Madison limestone. Today, runoff from the Amsden trickles down, staining the Madison's cliffs. Later in the Pennsylvanian period, beaches and dunes formed. These make up the Ten Sleep sandstone. The convoluted base of the Ten Sleep illustrates the impact of high-energy waves on the Amsden surface. How do geologists determine the origins of these rocks? Consider these ripples in the Ten Sleep, in the present, Structures like these form because of wave action. Therefore, similar structures, though millions of years old, must be the result of the same process. In geology, the present is the key to understanding the past. These are the rocks of Bighorn Canyon. Outside the canyon, however, are rocks which formed after the Tinsley. Estimates range from 5,800 to 7,500 additional feet of rock, covering the past 220 million years. The most colorful is the Chugwater Formation of Triassic age. Its iron oxide-rich sediments stand out at Horseshoe Bend at the south end of the canyon and near Fort Smith at the north end. The most fossiliferous formation is the Sundance, deposited in a vast sea during the Jurassic period. It contains the fossilized remains of belemnites, squid-like animals of 170 million years ago. Richly colored sediments also occur in the Morrison and Cloverleaf formations of Jurassic and Cretaceous age. These have yielded dinosaur fossils. Away from the canyon, these younger rocks lie beneath Bighorn Basin. They once covered Bighorn Canyon as well. Near Horseshoe Bend, what remains of the Chugwater, the Sundance, and the Morrison and the Cloverleaf dip away from the canyon into the basin. What happened? About 80 million years ago, colliding tectonic plates compressed the western edge of the North American landmass. The continent rose. The sea, present during much of the Cretaceous, retreated. This period of deformation is called the Laramide orogeny. Evidence of such compressional forces can be seen at the entrance to Bull Elk Basin in the striking geologic feature known as the monocline. At the monocline's base, the top of the Madison limestone lies 400 feet above Bighorn Lake. East of this, however, the Madison has been uplifted to over 2,000 feet above the water. Laramide deformation is also present at Devil Canyon. Here, the canyon's rim lies 1,000 feet above the water. From atop Devil Canyon overlook, a rise can be observed, away from which the rock layers dip downward. Ultimately, Bighorn Canyon exists because of erosion. Erosion's most effective agent is water, here in the form of the waters of the Bighorn. Initially, a gentle gradient allowed the river to meander. As it meandered, the rock layers it crossed were vulnerable to erosion. All traces of them have since been removed. Once the river encountered the formidable Madison limestone, however, the water cut down like a saw. The river's winding course became entrenched, thus creating the lofty canyon walls of today. The natural corrals, located across from Devil Canyon Overlook, once held the waters of the Bighorn River, but now lie high and dry. Shortly after the river eroded into the Madison limestone, it cut through the wall separating the river's bends and took the shorter course, leaving behind an abandoned meander. The Bighorn River's course falls within what geologists call a meander band, the width of which remains significant even after the associated meander spurs have eroded away, as has happened in Bull Elk Basin. Here, uplift has forced the river to erode past the Madison limestone into less resistant rock layers. The canyon, consequently, has expanded to the width of the meander band. Eventually, however, the walls of Bighorn Canyon will recede along its entire length, for the river is not the only means of erosion. Along the canyon's walls, rocks succumb to weathering. Rockfalls illustrate what lies ahead for even the most durable of these formations. Bighorn Canyon, remember, is dynamic, a place of never-ending change. The tranquility here may belie the constantly shifting nature of this landscape. Geologic knowledge allows for a better understanding as to why this canyon exists. Hopefully, such knowledge leads to a greater appreciation of the scenery. Along with a sense of duty to protect it. The canyon's beauty can inspire us. Its serenity, meanwhile, hides the powerful forces that continue to shape Bighorn Canyon.